Hello, everyone, and welcome to our podcast, The Manufacturing Show. I am Arjun, the co founder of Grovia, and today we have an exciting guest, Kevin Davis from Energy Quotient. The theme for the podcast today is Power Intelligence for Modern Manufacturing, Preventing Loss and Reducing Energy Costs. Welcome, Kevin. It is great to have you.
Thank you. Great to be here. Happy to talk to you.
So Kevin has a background in energy and optimization in industrial systems that has led him to build a platform that monitors and analyzes the invisible electrical issues. These are the issues that basically cost us by causing the downtime to our equipment. So if you're in manufacturing and have ever scratched your head wondering why machines are acting up, it might not be mechanical, it might be electrical that is causing the issues. And Kevin has developed a solution that helps to solve these issues by bringing tech to power. It is great to have you, Kevin. So, Kevin, can you take us back to the moment that sparked Energy Quotient? What did you see that others were missing?
Yeah, I think there were two layers there to the journey. The original work of developing just power monitoring dated back to when I was a faculty member at University of Hawaii. And at that point, we had some studies going on, some research going on with grid monitoring, power monitoring at the grid level. And we realized the limitations of that measurement equipment, and the data that was coming back was just not usable for research purposes. The quality wasn't there for what we needed. And so we realized that the equipment that we needed just wasn't on the market the way it should have been, right? And we had an opportunity to start building some of our own circuit boards, our own work to do that. So that was the first sort of spark to realize that there was a gap in the market around measurement capability, right? And then the second degree of sort of effort was just realizing the convergence of power quality and energy, right? At University of Hawaii, that was mostly about energy level, like real and reactive power flow, voltage, current, those types of things, which are just general power measurement, not power quality necessarily. And then realizing that the same devices that can measure that slower information for root mean square voltage and other things can also, with a bit of effort, do much higher speed sampling and measurement that is able to do what we really need for power quality. So much more sophisticated measurement capability. And with modern chipsets and modern software, it's now possible to do both in one device. And so that's what we are doing. And that convergence allows you to do so much more on the same platform. So those are the two sort of, convergences of capability and interest. And then just realizing the scale of power quality issues, right? We don't really talk about it a lot. I'm from the US, but at least I can speak here is, everyday people think about, is the power on or off? Like, did the power go out? And they're really frustrated with that when it does go out. Fine. But you don't really realize that it's not a binary. It's not an on or off. It's the quality of the power. It could go over voltage, under voltage. It could be frequent harmonics present. It could be ripple effects that most consumer electronics in your home, you don't notice anything right away. It might be a flicker of lights that's annoying. It is in some cases damaging the motor in your refrigerator or things like that could be over time damaged by overvoltage events. In the industrial area, there's a lot more cost at bay, right? Like you're dealing with much higher cost of equipment, much higher cost of the processes than anything residential. And those types of effects of overvoltage can really cause big damage and cost. And from the energy standpoint, you also have a lot of opportunities to reduce your energy usage, or even if not reducing your energy usage, reduce your energy bill. And so there's a lot of techniques and things that we can grab the data from that will lead a customer to the right direction to save.
Okay, that's interesting. So we were just discussing about like the power quality and the energy issues that you were tackling. Could you just help us understand how widespread is this issue, and are most manufacturers aware that bad electricity is costing them?
Well, I think that right now there's a set of manufacturers who really have seen issues, that things going down in strange ways that they don't quite understand, and they might suspect a power quality issue. There's that group of people. There's also the people that it's just an unknown unknown, right? And it's been said that that 7 out of 10 equipment failures that we don't quite know the cause of are due to power quality, right? But the data does
Okay.
not exist really in the commercial market to be sure of that or to diagnose it, right? And so that's the gap that we're trying to fill, that when equipment fails and nobody quite knows what the source of the problem is, that we can pinpoint that much more quickly, right? So I think that there is a lot of ground here where issues are either going undetected, just right below the surface of failure, or when they do fail, you don't quite isolate it as a power quality issue. But there's quite a lot there that I think we're just starting to.
So how do you plan to increase the awareness among the customers about these issues? And how do you plan to increase the sales for your company?
Yeah, it's just the whole normal effort of just getting the message out there. It's one message at a time. It's one post, white paper, one outreach. It's just I
Hmm.
don't have any secrets to that necessarily, other than just keeping at it really, and then being patient with that. Winning the respect through actual solving problems and word of mouth, honestly, like going out and having
Hmm.
that chance to prove a product or that we solve a particular problem, and then turn that around for the next person. I think it's really just that.
Okay. So people need to experience it to believe it. So that is the basic idea, I think. What exactly EQ system is? Is it really a hardware or software, and how exactly this works behind the scenes?
So we're a hardware and software company. There's sophistication in both layers, and we are hardware because our sensor, it's a custom sensor with a custom circuit board and built up. That's here. That allows us to get continuous waveform data. So 224,000 points per second of voltage and current measurement, and those points are going through data processing, right? So there's a lot of backend software that's going on to be able to process that data, save it, pinpoint issues, log the information. And so we're definitely building up more and more software on top of this, including even
Hmm.
AI. So at the top layer, we have an interface that would be facility managers that they can dial into the system, see the alerts that are important, have a clear indication of what happened, and be able to actually ask the AI to give more information or more context. And so the idea is that you basically have a power quality expert kind of at your side to work through things, right? If you were to say probably more of a software company than a hardware, but in order to get the data that we need, we have to be a hardware company as well.
Okay, cool. So, do your users need to be technically experts to use your products, or is it a very user-friendly?
Yeah, well, we're nearing completion of this dashboard that will be geared towards everyday facility managers who at least know their operations and know their concerns, but don't have to be a power quality expert. That's the goal in the AI. We're still building out all the models to be more and more sophisticated about particular issues.
Okay. So, you just mentioned about how to use this product and what exactly are the functions of this product. Uh, are there any real-life case studies that you could share with us? And has there been any aha moments for your customer?
One thing that is interesting that starts to become apparent in this equipment is the electromechanical interactions. So electricity powers equipment. That equipment has some mechanical action, and that mechanical action causes there to be a measurable current load or change, right? And so one thing that we can detect is where there are electromechanical oscillations. So if there's a resonance in some rotation of machinery or things like that, that will show up in electrical signature. So it's a kind of interesting thing that people don't think about a lot, that it's not a one directional thing. It's not just you're powering the equipment, and when that equipment does something mechanically interesting, it feeds back into the system. And since your whole facility is interconnected, those effects, which are noisy, they can propagate and they can reach other pieces of equipment that might be sensitive and cause trouble. And so I think the thing that is sort of an awareness thing for all of us is just realizing the complexity of power quality, right? Sometimes I think about it like a pond and a bunch of waves and ripples, right? Like ideally everything's smooth and it's a quiet morning with no breeze and everything's calm, right? And if you if if you drop a stone in the pond, you can see, hey, the ripples happening. It's caused from there. You can see it. You can track it down. But when things get really windy, when things get really noisy, a lot of waves, you don't know where a ripple came from or where a problem came from, and so it takes a lot more data and sophistication to isolate that. And so just that thinking that, again, power is not binary. It's not on or off. There's a quality to it. And that quality actually has multiple dimensions, right? It's not, is the voltage within spec? Is the frequency in spec? What are the harmonics? The balance of phases? All these things are aspects of power quality. So that's a learning piece that is challenging to explain because it's so abstract, right?
Yeah. Yeah.
But once you start to think about that in terms of these ripples or these effects that propagate through your facility and can affect things, then you start to think, well, maybe this piece of equipment, maybe you have a high powered robot or some sort of actuator that has a lot of inrush current or things like that. And if that a piece of equipment is close by or on the same circuit as something that's more sensitive, well, you might have problems, right? And you don't really think about that until you put a piece of measurement equipment like this on it, and then you can really isolate and look at the problems, right?
Okay. So definitely, uh, it is again something that is unnoticed, and people need to experience that and need to understand much more deeper things, what is going behind the scenes, and then only they will be able to experience the results of what happens when we correct that harmonics issues or voltage issues that we're seeing. So having said that, what would be the ideal use cases for this equipment?
Well, advanced manufacturing is the starting place because it just the cost of downtime is just tremendous, right? And so
Yeah.
if we can prevent that, then that's just a really important thing. But we're also seeing a lot of other applications and customer interest coming out of Department of Defense, for instance. Just being able to measure power quality there is important. Lots of reasons, stability of power and sensitive equipment that's there. Even high-rise buildings with a elevator. There can be a lot of inrush current when these elevators, lift and then break, and that can cause ripples into the rest of the building. And so there's definitely studies that we're involved with there to look into those issues, and that is leading into, in some of these buildings, there's a whole need for sub-metering, right? Because a high rise will be subleased in a lot of ways with a lot of tenants, right? And each of those tenants have to be able to their own use. And so there's a whole sub-metering, industry there. That industry now is becoming more and more interested in power quality itself. So when you're sub-metering, you can also be measuring power quality, and the whole, I think, movement, I don't think the industry is there yet, but I think the movement is towards power quality as a service. Like, can you guarantee a certain degree of power quality because maybe you have a certain process that's really sensitive? Can a company like us come in and provide and guarantee a certain degree of power, right? Without ripple, without all that. And that's the way I believe the industry needs to move. It's a lot of pieces I have to put in place to guarantee that, but that's a pretty big thing. We're seeing medical technology as another one, just because of the imaging and the tolerances there are really important. So really, I mean, it's pretty much everywhere where we're seeing a lot in data centers. As data center growth is coming online, it's becoming apparent that the power quality in the surrounding areas degrades, right? So when you have this data center, which is just a massive amount of power. I mean, in some cases, you could kind of draw an analogy to putting the power of a small or medium sized town in the size of a shopping center. I mean, it's dropping in a lot of power and a lot of density that is not typical for the electric grid. So you can think with that, there's going to be effects, and there certainly are. There's ripple effects, if you will, out into the surrounding area, up to 20 kilometers out. There's measurement of quality issues, and those deal pretty deeply with how that data center has their power configured. A lot of these data centers are running with a battery major backup that can back up for a small amount of time while they bring a diesel generator online. So that
Okay.
sort of power electronic, of course, those batteries has to be charged. And then when something happens, they switch off, they isolate from the grid, and those batteries turn on. So anyway, that high power electronics is what causes all that challenge, right? And just in general, in the utility, in the electric grid space, there's just more digitization, more electrification in general, right? Whereas you used to have a bunch of just mechanical direct drive machines that would rotate with lots of inertia, and that inertia, it smooths things out. I mean, it's not digital, it's not switching, it's just smooth, right? And now, there's just less of that, right? We have wind turbines, we have PV that are generating power that are not rotating. Well, obviously wind turbines are rotating, but they're not synchronized to the grid with the inertia directly coupled to the grid at the same
Okay.
time. So there's that. It's just basically at the small level, what's happening is it's transistors that are chopping that power, tens of thousands of times per second. Well, when you chop that and they're creating what should be a perfect wave. Well, it's never quite perfect, right? And so there's ripples effects of that, harmonics, you'd say. There's also interactions and dynamics where, one piece of equipment might it has an internal control system. That control system is going to react to the next device, and there can be interplay that you don't expect that can cause oscillations among devices, not just within a device. There's also more, you could say, variability around power. Volt, Voltage is kind of like the pressure, right? It's the pressure for the electric grid, right? And it should be at a certain level, wherever the nominal voltage is for your area. In reality, it's never exactly that. It's a little high, a little low, and there's bands or specifications for that. Well, when you run more current, more power, that's going to kind of pull that voltage down a little bit, at least. And when you push power back, you're gonna go up a bit. Normally, you have to keep within bands. That, let's say, that flexibility, like for a given push, how much does that voltage change? Inverters, let's say a photovoltaic, a solar inverter, has much less, we call it short circuit current. So it's much weaker. If you push in the voltage, it's going to push on the current. It's going to vary that voltage more. And so just the stiffness of keeping that voltage anchored to what it's supposed to be is much looser, let's say. And so it's just more prone to these oscillations, like as you have an inrush of a elevator motor, or you have inrush outrush, really, because it goes both ways. You're going to see that voltage just have more variance because there's less sort of old school mechanical direct drive motors and generators on the grid, right? Frequency is the same thing that, best in a lot of countries at 60 hertz, in other countries at 50, but it's supposed to keep within that bound, right? When there's perturbations, when there's extra load, that will drive the frequency down slightly, and there's a correction effect which keeps it very tight usually. But the effect, that frequency is sort of anchored very nicely by that rotating machinery. Like literally, like you can't slow down that flywheel but so quickly because there's a lot of energy in that rotating mass. Well, there's just less rotating mass now with those inverters and things like that. So frequency now varies more. So all these dimensions, voltage, frequency, harmonics, all these things are now more prone to challenge. And meanwhile, you're having more and more manufacturing and advanced operations, let's say in general, that demand higher degrees of power because things are more sensitive and everything else. And so there's just a real challenge. I mean, utilities are really up against a lot of trouble here. They got data centers that want more and more power, more and more EV charging, which is raising the load growth on the electric utilities. And so they're really in a hard place to manage all this properly, right? And so, our goal here is to provide more measurement and analytics capability so that we can be more strategic about increasing that power quality in the midst of all these challenges we're up to.
This really seems to be a vast scope for implementing this. So how do you plan to grow or scale up your company, and where do you see your company in next 3 to 5 years?
Well, in general, we're moving to more sophistication with software and ultimately
Okay.
as software as a service. So like providing that analysis capability on an ongoing basis backed by our hardware. Um, with anything that higher level sophistication of the AI and being able to solve all the suites of issues we want to solve will take a lot of time, right? To really dial that in. And so over time, we hope to increase that software capability and that software subscription as a service, like what it's able to do versus what we need to do as engineers, as power quality experts ourselves. And so that is the evolution that we're up to over the next year to year and a half, is bringing these projects that are very engineering intensive to solve a particular problem and automating more and putting that in the pipeline so that we can scale to hit a larger range of customers. So that's a big effort right now. And then, layering in the energy services on top, right? I see this as a value stacking. There's a real pain point around power quality. If we can
Hmm.
solve that well, there's strong value there. But on top of that, there's the capability to, reduce energy usage, lower your electric bill. And so building out those services as well is a big effort in the, let's say, the 1 to 4 year range as well. That's basically and then scaling through the markets, right? As we want to focus on advanced manufacturing, but also, Department of Defense, in light commercial buildings, medical technology, obviously, just building out the suite of services we can give to more and more customers, and then of course utilities as well. So we're working through the hardware level, getting that polished out and ready to scale. Again, the demo unit is prototype unit is it's working well. We're working to get that through certification, so that we can sell more. If we scale into utilities, we'll need to build a unit most likely that's weather resistant, able to install inside transformers in other places. So that would be another effort in the 2 to 3 year range.
Okay. So yeah, ecosystem definitely has really ambitious plans, and we wish you all the best for your future. So your customers would be interested in availing your services. How can they get in touch with you?
So the web domain is eq.systems. You can email me, Kevin at eq.systems. We also have a presence on LinkedIn. We're building out more in our website, so there's going to be more coming there soon. We're ramping out into a beta test program so that we can install these in people's facilities and solve issues. So that's coming out soon, and you can go ahead and reach me about that. Yeah, that's the main channels of contact. But happy to talk to anybody really. I want to hear about the problems. I want to understand what people are up against so that we can, as we're finalizing this product, we can really hit these problems. And so I just encourage everybody to reach out to me. Happy to talk through problems, even just brainstorm solutions, that sort of thing, as we're ramping this up.
Now that there are many founders who might be looking to tackle unsophisticated infrastructure issues, what would be your advice to them?
Yeah, I mean, as an engineer, I kind of gravitate and encourage the engineering mindset around this whole thing, right? Like really understanding the problem, understanding the pain point at a deep level, not just surface level, and coming up with the solution, trying to refine that solution to be a bit more cost effective or whatever the major points are that people need it to be scaled commercially, and just really refine that. But I think the biggest challenge for me is honestly in the investment part, right? Like it is really tough. I would say even tougher than solving the problems or even finding customers. And because in these hard problems like this, a system that needs hardware and software that was pretty deep in the engineering of this whole thing, and it's in a fairly abstract concept like power quality, it's really and the one that people don't always hear about. It's really hard to break through because the cycles of funding go largely to the things that already grab attention. So, AI or, sustainability previously, or just whatever those trends are, there's a sort of piling on effect. Like, okay, if you're a company in this area, then you get just a lot of attention, right? If you're solving a hard problem that is kind of under the radar, but still really important, in industrial space, for instance, it just doesn't get that sort of buzz of attention. And so you have to, as a founder, you have to be prepared to just play the long game, honestly. Like, buzz might come more if you're able to solve the problem, or maybe you just don't get quite as much of the buzz, but you generate the revenue. And honestly, eventually investors will see the revenue and see the problem solved. And at that point, but it's a long haul. It's a hard thing to do, to bootstrap and work harder at it, to build this thing when, you're still solving an issue that not enough people know about. It's valuable because if you can get there, then you can be one of the first, right? And that's awesome. But it's it's a hard journey, I'd say. So yeah,
Yes.
of course I advocate for the engineering side because I think engineers are very well positioned to analyze all angles of this, including even the business sides of this whole thing. So I come at it from that angle. I think the other aspect is just the team you build around you, finding the right people, syncing up them really nicely, and really being on the same bandwidth of everything. And I've been fortunate now to link up and work with quite a lot of talented people and build this thing. But it takes time and networking even to find those people who believe in you and work with you nicely, even when it is still early. It's fairly, you'll see as you try to reach out to people in various ways, you'll get all sorts of responses. One might be like, you explain the thing and you think you're explaining the value statement, and they're like, what's the value statement? And you're like, wait, I thought I just said it. But your engineers talk much different than business people, right? You could say what you think is your value statement as an engineer, and if I'm talking to another engineer, they might really get it. But business, it needs to be in a totally different language, a totally different high level of speaking, and learning that language is a thing in itself, right? Um, yeah, and so there's just all these levels of that, and you also notice that the response you get from people can vary everywhere from that. What is your value statement? Well, if you did your best to convey the value statement and the person didn't get it, you're probably not going to win that one.
Right.
It's you either got to get either better at explaining it, or just it becomes more obvious, or whatever the reason is. It's just probably not going to work at that point. And then there's others that they see what you're doing, they think it's neat, but for various reasons, all sorts of reasons, they're just not going to commit to support, or in whatever way they might, or as a customer, or as an investor, or as whatever capacity you were looking for that person to be involved. They see enough, but they're just not in a various position to jump on. And then there's those that really start to see it. I started to connect, and you kind of feel it, whatever else, and like you really gotta like just line up and treat those people just the very best you can, and just run with it, right? And because that's your core team, that's your either people that are going to be developing this with you, or your customers, or whoever's able to make those early bets with you when it is still not the obvious choice, when it is still somewhat risky. That's the team that you really sort of build from. And then later on, I think it becomes more and more obvious that your capability is there and the problem makes sense. And then that larger group, kind of naturally grows, I think. But it's a hard road, because you realize as a founder, the risk that you're taking on early, it's tremendous, right? Like, it's a lot of risk. Like, the thing could physically not work. It could, not meet the market, all sorts of reasons. That risk, every day, everything that you're pushing through is lowering that risk, right? And so you're just trying to drive this risk down to where it's inevitable, where it's definitely going to work as soon as you can. And so just notching up that as quick as you can, but realizing that everybody has their own risk tolerance, risk adversity.
Right.
Right? And so their point of which they're willing to engage might vary a lot. And it's been a bit of a wake up call for me, realizing the risk curve of investors, even early investors, is already much lower risk than you have to take on as a founder. And so
Right.
how you, with limited capital or runway yourself, build up a complex system and de-risk it enough that start to get their interest is that's a hard one, a really hard one. And so you have to be in it to win it, and just be like, hey, I'm going to grind
Yeah.
through this. I see the vision. Again, I come from the engineering side, and I know, and I've known for a while, that this is a pressing issue. This is a problem that needs to be solved. It's a problem that's worthy of being solved. Is there enough money there? And just, it's a problem that the time has come and the technology is there to do this, right? And I don't have, that's been an unwavering, understanding of mine for years, right?
Right.
So when all these other things get a little shaky, you can't connect to whoever you think you want to connect to, or whatever it is, you can kind of return to that a little bit and kind of chalk up the various wins you're getting and let them compound. And yeah, it's just, I could ramble about this, but it's been a real journey, I'd say, to get through, to work through all this.
Great. So this has really been a fantastic journey until now for you. This is definitely a worthy advice for the founders who are exploring new ideas in the engineering sector and not really fancy ideas. It is about how you get it to the market, and that is where all the stakeholders are playing the major role. Your employees, the investors, the business systems, the and all that kind of infrastructure that you need to build. So that is the entirely different thing that you need to focus on. And that is really hard for an engineer. That is what uh, Kevin's advice is. So that is really useful. That brings us to the end of our podcast. And thank you very much, Kevin, for your wonderful insight. It was really great to have you. And we wish Energy Quotient all the best for the future. And thank you very much.
Thank you for having me. Yeah.
For all the users, do like and subscribe our channel. And if you would like to reach out to Kevin, his email address and website and the LinkedIn handle would be in the description. Thank you very much.
All right. Take care. Thank you.